We spoke about Moore's law, probably a million times today, and how it's dying or dead or not dead or whatever, depending on who you talk to. But the general consensus is that it's at least slowing down, right? So my question on that, and I would love an answer from each of you on it, is, we grew up, and I don't want to say we're all exactly the same age, but we're all in the same relative generation, talking about Moore's law a lot. I mean, and obviously our parents did too in computing. So what are we going to talk to? What are our kids going to talk about if Moore's law truly dies, let's say, what's the next thing? What's going to replace Moore's law as a conversation, as kind of that universal law of computing for, say, the next, 30 years or so? So Paul, go ahead.
Not exactly an easy question. I mean, there's two things. I mean, from our point of view, when we recently, it sort of felt that looking at the systems that we've been building for rendering, we're at a stage where, because of the incremental improvements, we sort of felt it doesn't feel like it's getting any faster, or it's not getting faster fast enough, and so forth. But actually, when we went back and had a look at 4 years previous, we realized just how much it had come, how far it had come, not just from the hardware, but a big part of it was the software improvements as well. So I think you can't really attribute all of the gain that's going to happen to hardware improvements, even though it's potentially going to be a lot of it. But there's two things: not just improving the hardware, it's improving the software as well. So different algorithms, and then different algorithms that might take advantage of different types of hardware. So obviously there's other types of experimental hardware that might be coming. Algorithms have to change to take advantage of those. So I think potentially the algorithms themselves could play a big role in getting more out of the hardware we've got when we've started to reach the limits, at least to give some room for someone to come up with the next crazy revolution in hardware.
Right. So actually, Mazhar, I think this plays well into the frequency age and kind of the end of that, and that Moore's law pretty much defined that, and now.
So I think the solution is writing better software. I just don't think it's scalable. I just don't think it's going to happen. Even though we're trying to be part of that solution, right? I think what's going to happen is the problem between marrying the really demanding software with really complex hardware is something that's so untenable that you have to come up with a systemic approach. What I mean by that is, I think the economics are going to force people to invest in compiler technologies, in technologies that actually automatically convert abstract code to hardware languages. So it's part of the solution is hardware vendors actually provide as high of abstraction as possible, but there's actually going to be emerging the sexy new job is probably to be compiler engineer. I work in LLVM IR. That's my thing. The next thing I think one of the important jobs is going to be compiler technologies, both front end and back end.
Yeah, I would definitely say the ease of use is going to be the key to making all this work in the future. But I would go a different approach, saying Moore's law at its base is double the performance every 2 years. It doesn't necessarily, if you take it away from transistor technology and say we're just looking at the fact of double performance, I don't think it's dead.
Right.
I think society, computing is going to require that. We can't not continue gaining performance. I think it's going to go up to, from a CPU level and say, hey, hardware is going to do it all for us, to a system level. And now you're going to have combined ecosystems of innovation where it's not singular. We don't point to the CPU to say, hey, you're going to solve it all. We have to go beyond that and all work together to solve it. Mm-hmm. But I think Moore's law will continue.
Good.
I think one other point is that computation is becoming more brain-like, which means that I think naturally computation is more parallel, which means probably there's hope, right? Right? We may have to just depend on distributed systems.
I think there's also a buffer there at the moment, because you talk about the hardware advances and, maybe we're coming to the end of Moore's law, but the thing is that there's still some slack in that, especially on the cloud side, in that cloud providers are not providing the very, very latest all the time. We're still easily 6 to 12 months behind the head of the curve. So there is a little bit of room, for us to continue into that while the other things come online.
But with respect to that comment, but even 6 to 12 months behind is still generally a much faster upgrade cycle than if you were buying your own hardware and throwing it away every 6 months and buying a new one, right?
That's true, but obviously the in terms of hardware, we're talking about a lifetime of maybe 2 years for a piece of hardware that that comes out that we can utilize. So typically the providers want to get as much as they can out of that investment and obviously use it as much as possible.
Sure. So, but I mean, in an enterprise context, we think of 3 to 5 year amortization on hardware, and
it's much better than it used to be for sure.
Right, and cloud at least gives us that 6 month cliff, right? So, sure, well, we can take it. I didn't finish my. I've got question number 2 and question number 3 still, but
just continuing the thread. In the past, the commodity has been the processor. That's the processing power. As we move forward, data is important. When you look at what's the biggest taxi company in the world, it's Uber now, and they don't own a single taxi. They own the data around it. So you've got these zettabytes of data. How do you process them? That becomes the challenge, not necessarily the processing around it. And then you have the social aspect.
Yes. Well, we do it and then we beg for forgiveness, right? Or that's, yeah. All right. So question number 2, and I promise I will walk around and give everyone questions. I just want to make sure that I get these in. Actually, in Paul Arden's presentation earlier, you mentioned the black box approach to rendering as a service. I don't want to necessarily call it a microservice. People think of different things when they think of microservices, but in our mind, given that we're high performance computing oriented and we like to have this idea of kind of segmenting services and making them available via API, it kind of is a microservice. Maybe you'll fire off a rendering job as a microservice, where today you may ask for the time as a microservice, right? But with that aside, I mean, what it spells out is effectively software as a service versus having to go and set up machines and load software and orchestrate them and all that stuff. So the philosophical question for you guys is, that obviously makes a tremendous amount of sense to pretty much anyone who thinks about it for more than 15 minutes. But what do you think it'll take for the masses to start thinking of cloud in that context versus, let me just go spin up instances, load my software, configure them, all the IaaS type stuff, right? What do you think it's going to take? Is it time? Is it more proof points? What in your mind is it going to take to evolve to that level?
So when you say the masses, are you talking about masses of software developers or masses of end users? I mean,
well, I think that's a good question, because you're right. End users are they use SaaS. They don't even email. They're doing their email, whatever it is, right? But I would say let's call it maybe like people who are familiar with cloud, who think they understand cloud, and they think of cloud and they think of instances, they think of IaaS, right? So I think they may be developers, they may be advocates, whatever it might be. Right? So
one of the only reasons I wouldn't have used the microservices terminology in my presentation is because of the audience, and it's primarily used in the SaaS industry and so forth. But really, that's what it is. It is more like a microservice. For us, I think the barrier for our specific application, we still have a barrier of usability that we have to overcome just in making our service easier to use.
Right.
Not so relevant to what you're saying. But I think, frankly, price is one of the biggest factors. So it's still the case that quite a lot of our users set up their own hardware and set up their own if they have to run something full time. So if their occupancy would be quite high, they'll quite often set up their own hardware, primarily because of price. If the price was not a factor,
right,
they absolutely would not want to manage their own hardware. There's no question. Any of our customers, they do not want to manage their own hardware.
Let me just clarify. Mike, I agree with you. My question was more not so. Let's assume that on demand makes sense for them, price wise, right? We still have, when we talk to the market about cloud, we still have people. What they hear in their heads immediately is, effectively just on demand hosting. On demand instances, infrastructure as a service, and I guess. I think the first point you touched on, which was ease of use, and I wouldn't say that's specific to your application. I would say that if the entire world was accessible via API, then we wouldn't be having this discussion, right? But in a way that was reproducible and easy to consume. But it's really more about how do we get people thinking that is the right way to do cloud? Is why don't you think about the problem you're solving, and then just find a service that solves it versus try to build the entire stack yourself and then try to build a service that solves it on top of that, right?
So I think our customers already do think that way. They're just frustrated that it's not actually available to them. So the thing is that that's what we sort of purport to provide, but the reality is still a little bit different. And I think at the end of the day, they do want something they can just call out, get the result, and throw it away. The problem is for us, you see the data, for example, in the configurators where you might render a jacket or something like that. You might have to load 3 gigabytes of data from disk.io to render that image. So quite often what will happen is, you might render, 10 people might render the same jacket model with different colors. So we'll load the data once and then we'll render it 10 times. But if you throw it away every time, so if you're creating and destroying these resources all the time, then you have that startup time to contend with. So starting nodes really quickly would help a lot, but it's still not going to overcome the problem for us because we can't get back to the state we're in quickly enough.
So just for the record, Paul would like our machines to start up faster in case he hasn't made that clear earlier. But he said it a few times, yeah. So we agree 100%. So anyone else want to comment on?
I'll comment. So basically you're saying that you go to a cloud, and I totally agree that it's really weird to be able to pick an instance where you may not know what the right size is, how many GPUs and how much memory and how much CPU, and it's just weird to start something up and then run it. The next step seems to be as a service, something as a service, REST API. Probably it seems as though the next logical thing is basically, functional level microservices to like basically the Lambda, right?
Yep.
Offering Lambda sort of functionality in the cloud. But it seems as though that, sort of history kind of repeats itself where, the data center is the new computer, or it should be, where you just submit what you want and your application is naturally dispersive. It has different functions that automatically are attracted to the right hardware. Some intelligent thing is figuring that out, and I would assume that's the future, at least I would hope so.
Right, but I think
picking hardware is not something that our customers know how to do. They don't know how to do it. They just come and ask us, okay, what do I need? Which server do I want to choose?
Yeah. So question number, unless you wanted to comment on that. Question number 3, and then we'll open it up. But it's perfect segue. You mentioned capacity planning, very, very complicated. And actually, I would argue I came from an industry where capacity planning was almost impossible, and yet our customers demanded it. I'm not saying it's easy for you, but you identified at least a 6-step process. It was 6 steps that was very logical, that if you actually had that data, and then, it takes some time and so forth, but it was actually a process that you could repeat. So I guess my question is, how far away do you think we are from being able to, assuming that we put everything behind an API and we make everything sort of self-configuring, how far away, whether it's years or functionality or whatever it might be, before the algorithm itself can say, based on a function of time or cost, effectively what Steve talked about this morning, which is, I want this done and I want it to run in a week no matter how much it costs, or I want it to cost $10 no matter how long it takes, or some combination of that, and then have the actual platforms automatically choose the right hardware and run the algorithm you want to run. Is that 10 years, 5 years, next month? What do you think?
I think to some extent you could do it today.
Right.
Certainly, obviously Nimbix doesn't have an auto-scale functionality at the moment, but you could write your own as well on top of the API that's there now. So I don't really see anything specifically preventing us from doing it today, except for the one aspect that you talked about, which was it's related to what you said as well, which is selecting appropriate resources for a particular job. And right now, I'm not sure how you would automate that process based on the type of information, at least for our jobs, the things that we get when the job comes in. There's not a lot to indicate what kind of resource it's going to need. So, for example, we can work out a floor of GPU memory that we're going to need in terms of the amount of GPU memory. We can say we're going to need at least that much. But there's things in the way the algorithm works that mean that's the minimum.
Right.
It could be twice that it needs.
Right.
We just don't know at the end of the day. So we tend to over-provision GPU memory pretty dramatically, because failing in that respect is pretty catastrophic, because you fall back to CPU in our system. So we don't want to do that. So we usually basically tell people get as much memory as you can with GPUs.
But you do agree that that's basically like the nirvana, right? Is saying I want to do something and I want it to cost this much or I want to take this long, and then just not even worry about how it happens.
And those two extremes are definitely things that our customers have. So some customers say they want it as fast as they can get it, and they don't care basically how many resources they put it on. But the promise of the cloud, of course, is too that you can have it in 100 hours. Or 1 hour for the same cost because you can put 100 machines on it. Or
well, you're assuming linear scale and all these different things, but close enough. Yeah,
basically that's the sort of what we're talking about in Nirvana. Right?
Sure.
So that's the way that some people think about it. And then we have the other case where they might have a specific budget. So that's more on the retail side where they might say, okay, I know I can spend this much as a cost of sale based on the conversion information I have and so forth. And if I have that budget, I can afford to spend that. The only issue with retail is that having a hard cliff is kind of catastrophic. If you say, okay, I'm just going to stop serving images at this point.
Right.
There's I've reached my budget. I'm not going to serve anything more.
Right.
But those problems all exist with auto scaling anything, like auto scaling web servers. It's the same problem. Basically.
That's what I was going to answer is basically Steve's pitch when we started the whole day, right? It's machine learning. It's all built on machine learning too. You have to have some kind of predictive analysis to say, based on this job, this is the history of what happened, and I've learned over time this is what it's going to be. EDA has had this problem forever, right? You want to go submit, for my environment, submit a job to go test something or verify something. You have to say ahead of time, how much memory do I need? Right. Well, if you overshoot, you've wasted your company's resources, and you don't want to do that. So it becomes a predictive analysis problem, and then some guard banding of over-damping, under-dampening to make sure you don't hit those catastrophic failures. And I think the technology is there. Yep. It's just a question of,
do we have the will?
Somebody to go develop and have the will to do it.
I think the will is the thing that's missing because, that seems like such a, it is related, but I think that the connection is so tenuous for people. They think, well, I've just solved this other huge problem, using cloud resources. I've solved my rendering problem, for example.
Right.
And now we're saying I've got to use machine learning to solve the problem of just working out how many resources I need to allocate to this.
Right.
I think when that process becomes more commoditized, so for example, as machine learning becomes more commoditized, it could be applied to more what people see as simplistic problems, even if they're not simplistic.
Or even built into the platform.
Right, exactly.
So I can no longer hold the audience back. So
going on, like you were stating, and then cut it off or give you a warning of like you're using, this is about to cut off or you need to spin up something of that nature.
So they have that. So I guess I would say that the problem is not technical. The problem is that there's about 6 people that claim that this exists already. Right. So like Google's to say Kubernetes, that's what it is. Mesosphere, that's what it is. Data center as a computer. Heroku, is thinking about these auto scaling things. Right. Amazon's going to claim everything is elastic. Put together, it already exists. So the question is, does it really?
Well, it speaks to the maturity of the industry, right? I mean, all the pieces are there, and then it's just a matter of commoditizing it and making it effectively a utility, like you just spoke about.
Right.
Well, and you have to find somebody that has the market or business case to go do that.
Right.
Right. Because one person, if they restrict and say, I only need as much capacity as I need, whoever's doing that isn't the one selling the capacity, because I want to sell over capacity, obviously. Because so who's going to have the market potential to say it's going to save me money to go develop it?
Right.
Or make me money, one of the two.
Okay. So, sorry.
Can you, I'm an aspiring developer on the Nimbix platform, of course. So can you discuss the issues involved with like public cloud, private data, and protection of your intellectual property?
Of the intellectual property of the developer or of the people you're working for?
Both or both. Yeah.
I mean, frankly, we get the question. We deal with a lot of large enterprises, as I'm sure IBM wants to do as well. And we get the question quite a lot, obviously, about data security and those sort of things. Frankly, the thing is, if we're dealing with someone who's not spending a huge amount of money, or it's clear they're not spending a huge amount of money on security themselves, I mean, just have to look at what is Nimbix or Amazon or these companies, what do they spend on security and securing their cloud compared to what some of our customers spend securing their own. So a lot of our customers, they put all their data behind some firewall they bought at Best Buy, and then think it's secure compared to putting all their data in, say, Amazon, where they can control everything, particularly well, or whether it's in Nimbix or whatever it happens to be. So usually the security in those facilities exceeds what our customers have. And we do have some customers that are very paranoid about data security or have legitimate reasons that they need to protect the data. So, for example, in defense and so forth, there are certain things you just can't do. So, in the public cloud. In our experience, we haven't found any particular issues using the public cloud. If anything, we've found it more secure because it is in one place with centralized security policies and so forth. So from that point of view, we haven't had an issue with it. And in terms of protecting our own IP, we've also not really found any particular issues with it. In fact, it's made it a lot easier for us to protect.
I'll just add a real litmus test. I was at a special group of financial technologists in Austin, and they had a panel discussion. The guy from VP from Amazon was there, VP from Schwab was there, Visa, etc. The Schwab guy just said, "Look, I know Amazon's more secure than I am. Let's face it, we're all using the same stuff. We're all using F5. We're using this, we're using that. And if I have a breach, I get my hand slapped. I get in trouble. If they have a breach, they lose all their customers. They're out of business. So they pay more attention to it, I guarantee you, than we do."
If you look to it, I don't like to keep talking about Amazon because we're, but one thing that Amazon do is that they have this general cloud survey that they do regularly every year, I think, which basically is an opinion, a survey of the opinions of people using the cloud. And one of the biggest questions they ask is always, what is your biggest concern about using the cloud? And if you look at that over the years, you can see the drop in people who have said that their biggest concern is data security. That's been going down and down and down and down. And we've had some customers in the last 5 years who would never have even said the word cloud within the walls of the company before, who are now moving almost all their stuff into the cloud or moving data into the cloud. The climate has changed a lot in the last 5 years.
Well, as you pointed out, the enterprise clients that are moving to the cloud, banks, insurance companies, hospitals, right? These are companies that have more data security needs than anybody else, especially more than I do. I don't care if somebody grabs my picture, right? Oh, well. What's that?
Banking.
Yeah, banking is one of them. So it comes down to the hardware of the cloud also, though. I mean, you can do security in software, and it's going to do pretty well. But when you start talking about virtualized systems, and you have this two users on the same platform, that security has to almost get down to the hardware level. And it's what hardware your cloud is built on will make a big difference in that security.
In our application as well, there's a somewhat more unique aspect to that, which is that a lot of customers we deal with, for example, we deal with manufacturers of a product. If they don't use server-side rendering, their only option is to send geometry to the client side. So they might send 3D data to WebGL to render it locally, which means they're sending some portion of their IP across to the client side. And a lot of our customers are quite nervous about that. With the server-side rendering approach, they don't need to send any data. It's just an image. In order to get anything useful out of it, the customer would have to render huge numbers of views and then do some kind of reconstruction, which is going to be extremely cost prohibitive to do anything with the data. Whereas if you're sending the 3D data from scratch, it's trivial to capture that. If you're sending it to WebGL, you can intercept that very easily, pull out the 3D model and go and use it. And we had cases where customers were sending their 3D data to the client to visualize, and not long after that, they were seeing parts coming out of China that were made from that 3D data. Parts which actually included their logos and moldings and all this sort of stuff. So completely replicated from the same data because they were making it available in that way. So using the cloud in this case has the unique benefit that you never have to give that data to the customer or to the end user in order for them to see what they're going to get. You just give them the image.
So that's the same argument that we used years ago for server-based computing and thin clients. And
right.
I spent like half an hour talking about how that's obsolete, but it's not entirely obsolete in every use case. So, which is a great way to say it. Anyone else? All right.
Did you? I think we had one.
No. Oh, I'm sorry. My fault.
I know we started off earlier talking about the Moore's law, so I just wanted to get your opinion on quantum computing and what that is. Just define it for me and how that is.
I didn't say it because I didn't want to seem naive, but because I've sort of read about it going back and forth in terms of feasibility and plausibility even. It is something that sits on my radar quite often because it's, in rendering, there's a lot of problems that actually end up being search problems when you sort of break them down into what they're actually doing. So, I mean, even not the rendering we're doing, but simple Z-buffer-based rendering, which old-style GL rendering, at the end of the day, it's just a sorting problem. So these can be done very efficiently on theoretical quantum computers. Unfortunately, ones like, for example, what D-Wave make are not providing the types of functionality, forgetting them for now whether or not they actually use quantum effects, but they're not actually providing the types of algorithms that can be used for the rendering applications. So they're a limited interest to us at the moment, but hopefully, you know, if something happens, that would be interesting from a rendering point of view. And there has been papers on rendering on the theoretical quantum computers.
Well, and in fairness, I don't know that one's plural applies to the D-Wave. I think there are one or two. I mean, there are very few.
True.
The main question is, well, when are you going to start mass producing these things? And they're like, maybe in like 20 years. You know?
But yeah, there is you know, because of the way that you could potentially encode geometry as a supposition of quantum states on this computer, it would potentially be a fundamental difference in the way you would compute for computer graphics, and could make it an enormous difference, but obviously still very theoretical.
What else? All right. Well, thanks very much to everybody.